Hello and welcome to the CIBSE Journal CPD Module 266, Ventilation Design under the Future Home Standard. This module explores the impact of the Future Home Standard on ventilation design for dwellings in England. The publication of the Future Home Standard. This module is brought to you in association with Eurovent, because your air matters. The publication of the Future Home Standard, FHS, makes ventilation design integral to a home's thermal and energy strategy. The FHS was established in England to align building practices for new residential homes with the Paris Agreement's 2050 net zero emissions targets. Initially announced in 2019, the FHS is intended to make new dwellings zero carbon ready as the electricity grid continues to decarbonise through enhancements to the 2013 building regulations. At the heart of the FHS is the goal that new homes must achieve at least a 75% reduction in carbon emissions over their lifetime compared with the 2013 building regulation standards. This is achieved through low carbon heating systems with heat pumps being the default, mandatory on-site renewables, efficient hot water storage and delivery, improved fabric insulation and air tightness, and ventilation systems that minimise heat loss while maintaining indoor air quality, or IAQ. As a traditional step towards the FHS, the government implemented the 2021 Building Regulations Uplift. Published in December 2021 and implemented in June 2022, this update tightened the requirements for approved documents F, ventilation, and L, conservation of fuel and power, while officially introducing approved document O to mitigate overheating risks. Following a major consultation in 2023, there were further uplifts to approved documents F and L. These were announced on the 24th of March 2026 and take effect in England on the 24th of March 2027 for standard works and 6 months later for higher risk buildings, or HRBs. There is a 12-month transitional period in place until 2028. The FHS was published at the same time as the Future Building Standard, or FBS, which sets the requirements for non-domestic buildings. Because UK building regulations are a devolved matter, Scotland, Wales and Northern Ireland each manage their own distinct legal frameworks and timelines to achieve similar net zero goals. Wales historically followed England's lead but now publishes its own standalone building regulations. It published uplifted versions of approved documents L and F on the 7th of April 2026, which will take effect on 4th of March 2027. In Scotland, building regulations are enforced through domestic technical handbooks. Scotland also introduced the new building heat standard on the 1st of April 2024, which banned direct emission or fossil fuel heating systems in new builds. Northern Ireland is currently behind the rollout. Following a pre-consultation review, the region is working towards a net zero ready standard targeted for the 2026-27 legislative window. The focus of this CPD is on the impact of the Future Home Standard on ventilation design for dwellings in England. Changes for ventilation in dwellings. The FHS is expected to offer two routes to regulatory compliance: the UK Standard Assessment Procedure 10.3, SAP 10.3, and the Home Energy Model, or HEM. The HEM is a new compliance methodology and is still under development. It may eventually replace SAP or SAP. Both routes use a notional building approach. This uses a reference building with the same size, shape and orientation as the proposed dwelling, but with the standardised specifications for fabric, heating, ventilation and air tightness to set tailored performance targets, which designers must match or better in terms of energy use, carbon emissions and fabric efficiency. Increased air tightness and reduced infiltration. FHS compliant buildings will be required to achieve lower air permeability than previous standards. The air permeability of a building is the rate that air passes through cracks or holes in its fabric. The benefit of an airtight dwelling is that it minimises unintended heat loss and heat gain through the building envelope. While this will improve energy efficiency, it means controlled mechanical ventilation is generally required to provide fresh air for occupants and to remove moisture, odours and pollutants. The FHS is notionally air tightness. The FHS's notional air tightness target for SAP 10.3 is 4 meters cubed per hour per meter squared at 50 pascals. For the HEM, a figure of 3 meters cubed per hour per square meter at 50 pascals is widely quoted as the intent. Both targets are more stringent than the approved document L1 2026 backstop maximum of 8 meters cubed per hour per meter squared and the current SAP notional value of 5 meters cubed per hour per meter squared for new dwellings. Approved document F 2026 classes FHS compliant dwellings with a design air permeability below 5 meters cubed per hour per meter squared at 50 pascals as highly airtight. As such, it does not consider the historic approach of natural ventilation with background ventilators and intermittent extract suitable for such dwellings, requiring instead a mechanical ventilation strategy or specialist design. To reflect this, the FHS notional building models require continuous decentralized mechanical extract ventilation or DMEV as the minimum to maintain indoor air quality. The shift towards continuous mechanical ventilation. The ventilation strategy adopted in ADF 26 is based on a three-pronged approach. Extract ventilation from bathrooms and kitchens and rooms where water vapour or pollutants is likely to be released. The provision of fresh air and to dilute, disperse water vapour and pollutants not removed by extract ventilation. Intermittent purge ventilation to remove pollutants from an occasional activities such as fumes from paintings. Designers have the option of providing fresh air to dwelling and using continuous supply fans or background ventilators. The minimum whole building ventilation rate for supply of air to habitable rooms should meet both the requirement of supply, i.e. 0.3 litres per second per metre squared of internal floor area, and the minimum rates based on numbers of bedrooms. ADF 26 requires one bedroom dwelling to have a minimum of 19 litres per second supply, with an additional 6 litres per second per additional bedroom, so a 5-bedroom property will require a minimum ventilation rate of 43 litres per second. For FHS compliant dwellings with continuous extract, the total of all extract ventilation should be at least the whole dwelling ventilation rate. Boost extract rates will be required in rooms where cooking or bathing takes place if the minimum continuous extract rate is lower than the minimum stated. 13 litres per second for a kitchen, 8 litres per second for a utility and bathroom, and 6 litres per second for a toilet. To deliver ventilation at these rates, ADF 26 describes 3 ventilation options. Natural ventilation with background ventilators and intermittent extract fans. This system is based on individual intermittent extract fans located in wet rooms, bathrooms and kitchens, often manually controlled or humidity triggered, with background ventilation provided by trickle vents in windows. This historic approach is generally regarded as inadequate for FHS compliant dwellings because intermittent extraction can result in stale air in living spaces and passive background ventilation allows uncontrolled infiltration and heat loss. As such, ADF states that this system is only suitable for use in less airtight dwellings, that is, those with a design air permeability greater than 5 meters cubed per hour per meter squared at 50 pascals. Continuous mechanical extract ventilation. This can be a whole house centralized mechanical extract ventilation CMEV system or localized DMEV. A CMEV system is typically located in a dwelling's loft space or hallway cupboard. Multiple extract ducts run to the unit from the kitchen, bathrooms, en-suites and other wet rooms, expelling to atmosphere. A DMEV system typically uses individual extract fans located within each wet room, kitchen, utility and WC. This system is the minimum requirement to maintain indoor air quality within the notional building models for compliance with FHS. Background ventilators such as trickle vents are required for both CMEV and DMEV systems. They are intended to be left open. Because fans run continuously, the vents can be smaller than those required for intermittent extract fans with a minimum equivalent area of 4,000 square millimeters for each habitable room. To ensure air is pulled through a dwelling, ADF 26 states that background ventilators should not be in wet rooms. It also states that minimum number of background ventilators installed must equal be equal to the number of bedrooms plus 2 additional background ventilators. So a 1-bedroom dwelling would require a minimum of 3 ventilators. Mechanical ventilation with heat recovery. Mechanical ventilation with heat recovery is typically a centralized system that extracts stale, moist air from wet rooms, while simultaneously supplying external filtered air to a dwelling's habitable spaces. A heat exchanger transfers heat from the exhaust air to temper the supply air. ADL1 requires the heat exchanger to recover a minimum of 73% of heat and to include a summer bypass to route supply air around the heat exchanger when outdoor temperatures are high, preventing unwanted heat gain. The ability of the MVHR unit to extract stale, moist air and supply filtered external air to a dwelling means there is no requirement for background ventilators. However, it does mean that dwellings have to be able to accommodate 2 sets of ductwork, supply and extract. IAQ and health more prominent. Ventilation controls, intermittent or continuous, may be either occupant operated or automatic. However, ADF 26 requires continuously running fans to be set up to operate without occupant intervention, but with manual or automatic controls for selecting boost operation local to the spaces being served. Automatic controls can include sensors for humidity and CO2, carbon dioxide, along with occupancy sensors. Section 2 of Part F sets out requirements for minimising ingress of external pollutants where dwellings are near road, traffic, combustion plants or industrial sources, and refers to CIBSE TM64 Operational Performance Indoor Air Quality and TM40 Health and Wellbeing in Building Services for the location of ventilation intakes. Where sources of pollution vary with the time of day, the standard acknowledges that fixed-rate, always-on ventilation may need to be managed dynamically. Appendix B adds detail. It sets out the levels of moisture and other pollutants that the provisions of ADF 2026 are designed to control. These are based on the World Health Organization or WHO guidelines for carbon monoxide, nitrogen dioxide, formaldehyde and total volatile organic compounds. Overheating and purge ventilation. Changes to approved document O overheating for England and Wales were part of the 2023 FHS consultation process. Following responses from industry and other stakeholders, the government concluded that a comprehensive review of Part O should be undertaken. Until then, the current 2021 edition incorporating 2022 corrections continues to apply. Alongside the provision of fresh air for occupants, the provision for intermittent purge ventilation is also required for each habitable room. This should be capable of achieving 4 air changes per hour or ACH, generally by opening a window directly to outside. However, if a wet room has no external walls and an intermittent extract fan is being used, the fan should be capable of extracting air at a rate to provide 4 air changes per hour. Implications for ventilation design. One of the most significant design changes under the FHS revisions to ADF 26 is that it is far more prescriptive regarding ventilation system design to ensure systems are efficient in operation. This could have major implications for dwelling design where a CMEV, MVHR system or even a DMEV system is proposed. For ductwork, the 2026 revisions require the use of rigid or smooth semi-rigid ducts for centralized continuous mechanical extract ventilation and MVHR systems, rigid duct for intermittent and DMEV fans, with the maximum length of ducting being 2 meters where practical. The length of flexible ductwork to be limited to 200 millimeters and only for final connections to fan unit spigots for CMEV and MVHR systems. ADF 26 now includes Table 1.8, which states the maximum allowable design static pressure for CMEV and MVHR ductwork installations. Alongside this, ADL 26 limits the maximum specific fan power for CMEV at 0.5 watts per litre per second, and for continuous mechanical supply and extract systems at 1.4 watts per litre per second. There is also an increased focus on verification for all ventilation systems where ducting lengths are greater than 2 meters. They now require a competent person to submit design calculations and drawings to building control to prove the system can achieve the required airflow rates without exceeding the static pressure limits. Space allocation for ductwork will need to allow for insulation. Where ductwork passes through heated parts of a dwelling, ADF 2006 requires it to be insulated with the equivalent of at least 50 mm of a material having a thermal conductivity of greater or equal than 0.04 watts per meter per Kelvin. Insulation for intake and exhaust ducts should be fully vapor sealed to minimize the risk of condensation forming. In unheated spaces such as lofts and floor voids, this requirement is reduced to 25 mm. To ensure these requirements are met, designers will need to consider ductwork routes for CMEV or MVHR units early in the dwelling's design. They will also need to ensure sufficient space for MVHR or CMEV units, typically in a utility room or cupboard. For an MVHR, access will also be required for maintenance and to change the filters. Commissioning and home user guides. The FHS sets out to ensure that new homes achieve their design performance. Commissioning of ventilation systems should follow the procedure set out in ADF, which has been extended. In addition, the FHS acknowledges that many homeowners will be unfamiliar with the operation of an MVHR, for example. To this end, ADL 1 2006 introduces Regulation 40C, mandating that occupants are provided with a user guide to give comprehensive, accessible information on the efficient operation of ventilation. Future changes. The Future Home Standard will offer two compliance routes, the HEM and SAP 10.3 as an interim alternative. SAP 10.3 will be the sole compliance route at FHS launch in March 2027. HEM will not be available initially and will follow a minimum of 3 months later. Once HEM is approved, both methodologies will run in parallel for at least 24 months. With the building services industry undergoing a paradigm shift as it strives to improve the energy efficiency of new and existing buildings and make them inherently safer, members of CIBSE need to focus their learning and development on key industry issues. Members of CIBSE and other professional bodies are required to maintain their professional competence throughout their careers. Please visit the link in the description should you wish to obtain a certificate to keep on your CPD record. Copyright in recording Joss Brownlee 2026. Text copyright Andy Pearson 2026. This module was brought to you by the CIBSE Journal. All rights reserved. The moral rights of the author have been asserted. Thanks for watching and listening.